Everything's set up. We're waiting, making sure everyone joins. My screen. Let me do that. Okay, do you guys see my screen? Awesome. Okay, good morning. We have a few things that I said we're going to do today. So going through one of the set covering exercises, going through a knapsack exercise, and reviewing class test 1. Then if we have some time, I just want to start with the combinatorial IP so that we don't have everything left for tomorrow, because there's an IP and an algorithm. It's fairly easy. It's just not everyone gets it right away, so then some time for exercises tomorrow would be helpful. Right, so let's get started. First things first, let's do that one. Just want to look for the question. There we go. Okay. So let's tackle this QB publishing question, the one that I said you should focus on. So let's have a look at how to attempt this one. And then after that, a knapsack, and then review of class test 1. Right. Marizon, depends on which subject you are asking. But if it's Math 281, which I had previously, I'm not sure. Class test 1 will be open. Didn't I make a post already? I think I already made a post about when it will always copy the times so that it's there. Yeah, it's a bit too early. You're definitely excited. But guys, please always check the announcements, because for the next test, it will not be me handling it. So then you just have to check who's going to then handle those queries about the next one, right? But for this one, it's me. And you'll see I said email me if there's something, but put in screenshots. Otherwise, it's hard to figure out what you're talking about. And then trying to figure out what's the problem, and then trying to figure out if there's a problem. Yeah. So just send me screenshots attached so that I can see exactly what you're referring to. And then I can check if there's something or not. Right. But I have checked that, like I said, question 3.3e, and I think it was F and G, well, technically G or something like that, where it was not asking for the new constraint, but some previous constraint in the table. Not a problem. I just checked if you by accident filled in then constraint 5. Because the previous questions were built like that, I then accepted also constraint 5, because I felt like you were probably in the go, so it was a bit maybe something you could have missed. So it's fine just for that one though. But be careful always in a test. Like what they ask, you fill in, whether or not it's, how can I say, you don't think it should be what they should ask. Like fill in what they ask. If something's wrong on our side, then we'll mark whatever you filled in. As long as you fill in what you should fill in at that spot and your answers are correct, we can obviously check that. Okay. So just to make it clear. So always follow instructions, whatever they ask, whatever they want, you fill that in, and we deal with it when we see it. All right. It's always a pleasure. Okay, let's tackle this one. Let's see. So yesterday, let's see. It's a publishing company selling books to university students. QB has 2 sales representatives available to assign to the 9 provinces. A to G are the provinces. Okay. The number of university students in thousands in each province is actually given in that figure. And then each sales rep must be assigned to 2 adjacent provinces. So while I'm going through it, tell me so long, what does it mean to say adjacent? Then, for example, the sales rep could be assigned to A and B, but not A and D. QB scores to maximize the total number of students assigned to the sales reps. Right, so what does adjacent mean? Let me ask you. And then secondly, it's very important that we take note of, we've got 2 sales reps and we've got how many provinces? Because I see in the thingy it says something. Let me see. 9 provinces. Are there really 9? No, there's only 7. Sorry for that typo. So there are, yeah, only 7. Okay, but yes, next to, adjacent means next to. All right. Yes, I will, and we won't talk about it. Okay, so adjacent means next to, so right next to. So as we can see the example, A and B can be covered, but not A and D at the same time. They must be next to, probably for traveling purposes. All right. Then, because we've got 2 sales reps, if it was only 1 sales rep, you would purely have an XI problem, because it would be, does the sales rep go to A, B, C, D, E, F, or G? Which ones? But when we have now 2 sales reps, we kind of have to be able to identify, but which sales rep actually takes which provinces. Otherwise, if you get to the constraints about adjacent, you're going to have a bit of a problem to say, okay, so just to explain, if sales rep 1 goes to province A, we are going to then make sure that that sales rep also go to B or C. Hear me saying or. B or C. But if I include sales rep 2, it's going to get confused with the fact that, okay, sales rep 2 could have gone to, let's say, D, that could go to C, B, E, F, G, but now it might not pick up, well, it will not, because you don't have a variable xij, you only have xi. It's just going to specify then, a sales rep is going to D, okay, but another one is going to A. But if we check adjacent, A is adjacent to B and C, where D is adjacent to all others. So it could have then calculated it to say, oh, let's take A and D. Even though you set it up adjacent, you have 2 sales reps that you have to put in. So it might see it as, yes, it's adjacent, but it could have seen it as you've got a different sales rep there, D, but you don't know if it's a different sales rep or if it just didn't take the adjacent correctly. But in short, you've got 2 sales reps and you want to know to which provinces they are going to. So you need some kind of way to say who goes where. If you just say XI and you say the sales rep goes to A, B, C, D, E, F, G, or what, it's just going to say a sales rep, not which one. So we need XIJ to say sales rep 1 goes where, and then sales rep 2 goes where. So you had to have an XIJ there to help you with this problem. So let me just write here, XIJ. I'll start I as my sales rep. So it's sales rep I going to territory or whatever J, right? So we have only 2 of them, sales rep 1 or 2, whereas J, we've got A province, 2 would be the B province, 3 would be C province, etc. I'll do it alphabetically. Right. So we now know what we're going to be dealing with. So let's see how can we set up our max objective. Why is it a max? Because they said so, but they want us to create a solution to maximize the number of students. So we have our max objective, total of students. Where do I see that? They actually tell us the total students, the number of students. As you can see there, the number of university students in thousands in each province, given in the accompanying figure. Right, so now I have to think, how am I going to put this in terms of the Xij I just created? So for this province A, it has a value of 34,000, but we'll just say 34 students that will be covered. So if that's the case, we do know that it could be either sales rep 1 or sales rep 2. But whoever takes province A will cover 34,000, or like I say, 34. So for each of these, sadly, you're going to have a value and a variable for each sales rep. So that if that sales rep covers that specific province, then that value will actually be included in the objective function. If they don't, then it's just times 0, because we're going to use our variables as binary to say either they do cover that province or they don't. Right, so if I take, for example, the 34 and I say X11, I'm referring to sales rep 1, province A, 11. So in that case, I'm going to have a 34X11 and a 34X21. So then it's sales rep 2, but also province 1. So if, let's say, sales rep 1 takes this province, then it's very unlikely that the other salesperson will also take this province, because you're going to have a lot of constraints saying, let's cover the most. So it's very unlikely to have them both covering the same province. So something like that would happen where you'll say, okay, so sales rep 1 actually takes care of this or sells to this province. Sales rep 2 does not. And if I take the values at the end, it's going to be then 34 times 1 plus 34 times 0. So it's going to just do it once or add it once for that specific sales rep that covers that area. So that's the idea. But that means a lot of work for the objective function, although it's simply just taking the values because you are maximizing the total number of students. That's why you're taking those values. So 29 would be for province 2, so 29 for province 2, and it's for sales rep 1, province 2, as well as sales rep 2, province 2. And the same you do for literally everything else. You can see that in the solution if you want to see that. Right. Do we have any other additional costs or profits or anything else? No, because they say maximize the number of students. So there's no adding a cost to the total number of students, unless if I'm going to sell the students. I'm sorry, I just had to. Right, but we're maximizing the number of students. Right? Yes, Armando, it might be. And we're maximizing the number of students, so there's no adding costs or subtracting costs or something a lot. Danilo. That's a good one. I would say, nah, you guys are worth a lot depending on where, you know. Let me not go into that. Hey. But anyway, so ouch. It's not me that said anything. All right. It's good to have a bit of a laugh in the morning, hey? Yeah, cheap labor. Yeah, you guys are going to be interns very soon. Make sure you're not going to fall in the category of cheap labor, hey? So check before you sign that contract. Let me see. I was just reading there again to see where was I. Okay, so it's maximizing the number of students. So if there was anything else to do with number of students, like if they visit that province, then usually they have like a good marketing scheme which attracts more students, but then they'll sell more. Yeah, then you'll add on and you'll have maybe some numbers that you can add on in terms of total number of students, right? But everything in the objective is total number of students. So you have to then focus on that for your objective. No. Yeah, hey, sure. Okay, let's see. So that's objective function. That's it for that one. But now reading further, I see the whole thing about two adjacent provinces. And I also see something about there are two sales representatives available to assign to, well, to 7, not 9, but to 7. What else? Each sales rep must be assigned to 2 adjacent provinces. So first of all, we need to actually make sure that they're assigned to 2 provinces. Usually your adjacent constraints might already sort this out, depending on how you set it up. So we'll set it up either or just to make sure you've got it covered. But before we get to adjacent, we're first going to focus on making sure that they at least go to 2. Well, not at least, they must be assigned to 2. So not an at least or less than, they must be assigned to 2 provinces. Right. Anika, let me see. Yes, 12. Let me see. 12x2, 1, 3. Let me just see. Was it 12? It depends on your order, of course. So if you went A, B, C, so C is 42. So I think that was just by accident. But yeah, that yes, that's better. But yes, that's it. That's it. Okay, so we're going to start with the adjacent, not the adjacent, but with the 2 provinces first. So I'll say here 2 provinces because they must go to 2 provinces. Right, so if they must go to 2 provinces or territories, we will focus on the adjacent later. We're just going to go and say it must be 2. So not can or at least, no, must be 2. They must go to 2, right? So equals to 2. Then we go and say, okay, but which ones? So remember I said this is the J, which goes from A to G. So there are 1 to 7. So just to make it clear, A to G are options for provinces. And we've got, sorry, I've got 100 things open, 2 sales reps. Okay, so now we're going to say, okay, but let's look specifically at sales, I'll just say sales R1, sales rep 1, to make sure sales rep 1 actually visits 2. Because as soon as we look at adjacent, we're just looking at whether the provinces are actually adjacent. We're not looking at whether the salesperson will see those provinces adjacently. We're just looking at adjacent. So we have this constraint, or actually we're going to have 2 constraints to just make sure that the sales reps actually do go to 2 provinces. We'll still get to the adjacent part. So 2 provinces, doesn't matter if it's adjacent or not. We just want to make sure if they go to any of these 1 to 7, that it's actually going to be equals to 2. Right. So sales rep 1, let's see. X, yes, Danilo, you're starting with a 1 because it's going to be sales rep 1 for all of them. And then J because it's from 1 to 7. And you say the sum of J starting at 1 and ending at 7. Or you will literally go and say X 1 1 plus X 1 2 plus X 1 3 ... until x1, 7. Although I would say equals to 2 because they are saying must go to 2. So there's no choice in if they can do more or less. However, I do appreciate it if you can argue the fact that, okay, they say they must go to 2, but if they can go to more, why not? So then I would accept that greater than. But you should be able to like argue that fact. Otherwise, I'm going to be like, why? My brain is saying something else. So argue it, and then I'll decide if it's actually valid or not, right? Or I might counter argue. Okay. But I'm going to go to saying they have to go to 2 and maybe not have resources for anything other than 2, right? So the must 2, I'm sticking to that. Right. Then this next one, yes, then everything's going to be x2j. So the sum of j starting at 1, ending at 7. So that's going to be 2, 1. Yes, I'm 100, 2, 2. Dot, up until 2, 7, and we set it equals 2. That's perfect. So you've got your first 2 constraints done and dusted. But this was specifically just for making sure the sales reps go to 2 provinces. Now we get to the tricky constraints. We now have to make sure that the provinces that they actually go to are adjacent. So this is binary though, so you are playing around with that whole conditional thing. But let's have a look. So it's a set covering. So we're going to first just identify what will be covered if they go to certain provinces. Let me think what would be the best way to do that. Okay, so kind of that table like before, but the constraints won't be exactly the same because you've got actually an OR here. So I'll explain just now. So if we look at maybe the sales rep going to, let's say, province A. Let's start there. Yeah, that went ugly. Let's start there. So province 1A, right? Let's focus first on, let's set it up more efficiently. So let's focus on A, sales rep 1. Right, so technically when we set these up, it should sort out the above, but if not, we do have those above constraints to make sure that they go to 2. Right, so let's focus on this one first, right? So let's see, sales rep, that would be sales rep 1, province 1, so x1, 1. Okay, so if sales rep 1 goes to province A, which other 2 provinces are options? Which other 2 provinces are options? Just make my thingy a bit smaller there. Yes, B and C, because they're adjacent. So we're going to need to include 1, 2, and 1, 3. Now, be careful not to include everything for sales rep 2. The reason being is if you've got everything for sales rep 2, it's going to be much harder to set up this constraint to get conditions that will make sure that you, let's say, for example, if sales rep 1 goes here, that it doesn't by accident take sales rep 2 as here, and then that would be accepted, which would be okay if they would then not be possible to have maybe, let's take it as when you get to E, then they could have done sales rep 1 is which number? 5, just to make it clear. So x1, 5, then we could have put them here as well because this constraint wouldn't have restricted them. But that is not possible due to the fact that it's not adjacent to A if we put it there. Right. So we're going to have separate constraints, sadly, which makes it a lot longer, but it's just duplication. So I'm going to show you exactly what I mean with this. Right. Can it undo? No. Okay, so I'm going to now show you the idea of this. So just to take note quickly, this is specifically for adjacent, right? The previous one, Anika, was just to say that they go to 2 provinces. So that, because they said they must go to 2. So we just covered the fact that they must go to 2 provinces. So you check sales rep 1, okay, must go to 2. Sales rep 2 must go to 2. Now we have to make sure, okay, are they actually adjacent provinces? Right. It's an assumption. So they said must go to 2. So the assumption is they wanted to go to 2. Technically, you should be asking questions then to say, okay, is it only 2? Can't they go to more? But because I said must, I'm assuming it's an equals there. All right. But that's why I said if you can argue it properly, then I'll think about it. If I can't argue about it back, like counter argue that. Okay. So always review and let me know if there's something that you can argue, and argue it from the beginning. Don't let me ask you, but why? Right? But in a nice way, like don't make me not want to give you the mark. Okay, let's continue. I'm wondering. All right. So then we're going to say, okay, how do I make this constraint? So this is a conditional constraint where we kind of have to make sure it meets all conditions, right? So we included this because A is adjacent to B as well as C. So if you then go and check B, you'll check what's adjacent to B. If you do C, you check what's adjacent to C. So almost like that table from yesterday. But you can't copy and paste those constraints. It will not work. And the keyword here is, now let me see if you can catch on. Okay, there's only one keyword, so probably not necessary. But we're saying if salesperson goes to A, they must go to two provinces, not all 3, to 2. So they either go to A and B, here are my keywords, A and B, or they go A and C, because they must go to 2. So I hope you see why I'm making the assumption, right? That if you made a different assumptions, your constraints would have been completely different. They would be very similar to the set covering we did yesterday. But because we're doing it in this way, where we say they can only go to 2 and they must go to 2, then we have to set up a constraint to do the or. So the or is our keyword there, or, right? So or is your keyword saying that, yes, it's one constraint, but there are 2 things that will be checked, okay? So let's see. If we say they are in sales rep A is in province A, they can either then be in B or C. So B or C are both dependent on A, if I can put it like that. So there's technically 2 things now dependent on A. Hint, hint, multiply by 2. Right. Okay, so let's get to the conditional checking. But hint, hint, that specific item that has 2 things dependent on it, you're going to have to multiply by 2. If there were 3 things dependent on it, you'll multiply by 3. If there were 4 things, multiply by 4. So that's just a trick I picked up over the years. Okay, so I'm going to have to multiply. But let's see, we're playing around. Right, so let's first get our Amanda, yes, because that specific one has 2 other things that's dependent on it. B does not have two other things dependent. It's just if you go to A, you also go to B. If you go to A, you also go to that one. Right. So just to make it clear, but it's always good that you ask. Right. So let's see. How can I set this up? Let's see our conditions. So let me ask you, should it be true or false if I do I really need brackets? Yeah, if we're going to multiply, let's do brackets. Should this be true or false? Remember we had that whole must, blah, 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 blah. Okay, so technically it should be false. I agree with you there because we said must go to 2. Now, we're going to struggle to set up the constraint if we make this. So now my other question is, don't we already have constraints limiting them to only go to 2? Yep. So this can be true or false, whatever makes this constraint work. So if you go and do the plus or minus and the times 2 and you don't get anything to get that as a false, then a true would also be fine because we already have constraints. If you played around and you see, I can't do anything to make this one false and the rest true and false like I need them to be, then I go add those constraints and then I can say, oh, true or false is fine. So, yeah, difficult. Hey, this was a very difficult one. Okay, but let's see what we need it to be. Let's first play around. Now the next one. Do you think this should be true or false, or is both fine? Thank you. False. I agree with false. The reason being, we're focusing specifically on adjacent. Right, we have those previous constraints focusing on the number of provinces. It's sorted. But here I'm focusing on adjacent. So if I don't let sales rep 1 go to B or C, that is going to be a problem because then sales rep 1 is going to go to one of the other provinces as well. So if I say this is true, it's going to be not a true or false. If I say this is true, the reason why it can't be false is, I say it can't be true is, if I say this is true, then I'm saying that something like this is allowed. So later on, when I have maybe B and something and something and something, I'm going to say B is, okay, let me not take B, rather D. If I say then D has sales rep 1 in there for one of them, I'm going to then say that's perfectly fine because here we said A and nothing adjacent is fine, which it's not, right? We don't want that to happen. We want to make sure that if it's adjacent, we pick one of these. If not, we don't pick it. So this should not happen. So focusing on that, let's focus on it in terms of we want it to be adjacent. If it's not, then we don't allow it. So true, we want it to be false, definite. The top one is a bit, it could be true, it could be false because we already have a constraint there. However, are they adjacent? Let's focus on adjacent. Are all 3 of them adjacent to A? Yes, so I technically go for true. So I hope you see where I'm going with this now with the it false made sense, but if we're focusing on adjacent, true would make a bit more sense, right? Because we already have those constraints covering it, right? But if you find something that works for the false, I mean, then you can go for it. It's just not, yeah, it does not work that well. Okay, let's continue. Let's see. What do you think about this one? Is this adjacent? True, yes. A and B adjacent, that's perfect. C is also adjacent, but we're now focusing on A and B just being chosen, but it's adjacent, so perfectly fine. If we pick this, is that adjacent? Even though not literally, but the provinces. Yes, the provinces are adjacent, so yes, I'm happy with that one. Now, what about zeros? Without me doing anything, if this is 0, do I then say false for anything else? True. Right, remember if this is 0, then we will not limit the other variables to be anything. So I'm not going to say, oh, okay, this must be a 1, or this must be also a 0, or this must be a 1. No, because we're specifically looking at adjacent to A. Right, so if it's adjacent to A, but A is 0, then I should not be saying the others cannot happen. I mean, we're going to have a constraint for B checking what is adjacent to B. So if I then go and say B and C, but I said here, oh no, if you don't, if cells don't go to A, they cannot go to this, then I am wrong, because if they go to B, they can go to B or C. So you cannot limit those if you're specifically looking at what's adjacent to A. Right. A lot of people would have said false, but that's not true, because if you say false there, you're limiting something that you're not even checking in this constraint. So if you went, for example, and said this is false, if this one is 0, then that should not happen. That's not true. I mean, they could have gone to these two. That would have been fine. Or they could have gone to this one, which is province B. Is only A and C adjacent to B? Is only A and C adjacent to B? No. We have D and E as well. So if you go and say, no, if A is 0, then that cannot happen, then you're restricting the other possibilities. Right, so you're going to make anything where A is 0 true, because you're not going to limit any other possibilities. Because if A is 0, this is not what this constraint is for. So anything, whether it's 0 or 1, 0 or 1, whoops, we can allow it to be true. But we should allow it to be true. If you make it false, it's not going to allow, let's say, for example, B and D or B and E. Okay, so these must all be true. Nice, but how do we set this up? Okay, so first things first, you can add, subtract, put your sign anywhere. This is quite a hard constraint to set up because you've got 3 of them. However, you saw yesterday with the set covering, we didn't have to multiply something. Reason being, so just to give an example, I can't remember the exact values, but it was something like if fire station was in 1, it covers 2 as well. Then it was 2, which covers 1, and I don't know, 3 probably, or something like that. But if you did this constraint, it was literally, if it's in 1, it covers 1 and 3. So there was no multiplying a 2 anywhere necessary, because they're literally, all of them are going to be done together. You could have played around with the conditions, of course, but there's no multiplication necessary. Whereas here, the keyword is or. So you have 2 separate things dependent on one main thing, which you're checking. So in that case, here on that main thing, you're going to have to then multiply by something. Right. So for these with the and, it was something like x2 plus x1 plus x3, something with the signs and the right-hand side, but there was no multiplication necessary. but due to the OR, it separates the two technically. I showed you last week how you could set up two different constraints and later on bring it back into one constraint. But hint, hint, there's going to be a 2 in front of something. If there were 3 variables, then there will be a 3. Not 3 in total, I mean 3 dependent on one. So meaning, let's say you had these and another adjacent one, then you can multiply with a 3. If it's necessary, though, you obviously have to check your conditions, please. These constraints are not just, you can't just study them. It helps to have a general study in general to have like, okay, I should try and put a 2 in front. Then you don't struggle too much, but it's not always going to work out for every single constraint. That's something you'll have to actually test and check. So you have your conditions and you're going to test and check whether it works for everything. Okay. So for the part that we now test. Yeah. So if we did a plus in between them, so I'm just going to go and erase my, let me not erase those. Just B, C, D, E here. So I've got some space. So if I go and test this, you can have some sign in the middle of some of them, but I'm going to just try and put a sign here. So this, this, or this, and some right-hand side value. Then remember, if you do that part, you want to make sure you include all the ones, all trues, and you exclude all the ones that are false. Right. So that's how you would make sure that all your conditions are met. If the trues are included and the falses are excluded, you're meeting all your conditions. Right, then you can play around with a plus or a minus. Plus or a minus doesn't have to be the sign between them the same, but if you go down, it must be the same sign. So like that. That must be the same, because when you write a constraint, you must use only one sign. You can't write different constraints. So it's same, but between them can be different. I can give you a hint. It won't be different due to the fact that it's the same thing. B is adjacent to A, or C is adjacent to A, but it's the same concept for both B and C. So between them, you'll have the same sign. We just have to figure out which sign. Right, so just to do that, which sign? Okay. So I'm going to put that 2 in. Let's leave the 2 for now just to see if we can do anything. Right? We have some time. Let's see how it goes. Hope it doesn't take too much time. So we say, okay, what is 1 plus 1 plus 1? It's 3. What is 1 plus 0 plus 0? It's 1. 1 plus 1 plus 0, that's a 2. Excuse me. Then that's a 1 plus 1, so that's a 2. And then that's a 0 plus, but I can already see something. Would I be able to include the trues and exclude the false? Yeah, I can make it equals to 2 so far. I hope you guys can see it so far. I'm not done, but so far. Just to see if we gain somewhere. If I make it equals to 2, I'm including all the trues, but not the false. But we said we want this to be true. So what now? Will that be possible? Will that true be possible if I say equals to 2? I'm just playing around to give you some information in between. But will that be possible? If I say equals to 2, but that one gives me a 3. See, Danilo is typing, so I'm assuming I'm waiting for that. Just to see what you say about that, yes. But technically, if it's not included, it's a problem because I want it to be true. If we want it to be false, then it's fine. I hope that makes sense. So if I want it to be true, then equals 2 won't work for that. If I want to take a false there, well, then it's fine because 3 can then be excluded. Okay. Let's check the rest though. If it's a 0, we said that must be true for anything here, meaning 0 plus 0 plus 0. Right? 0 plus 0 plus 0. Will that be then included with the equals to 2? I sent a message now privately, so I just wanted to apologize in the tests. If I'm very not so friendly replying, just because I've got a lot of messages coming through or I'm busy. So then I just reply quickly. So if I don't greet you back or something, it's not that I want to be rude or something. It's just I have to respond very quickly. I was just thinking about that. Sorry. But anyway. Just because I sent a message now to someone privately. So it's like, I'm not rude, it's just I have to respond quickly. All right, so going back here. No, thank you, Kenneth. No, no, no. So if something like 0 plus 0 plus 0 equals 0 should be giving me a true, and I use equals to 2 due to those, I now have a problem. So if you now go say, okay, but let's try then, I don't know, less than or equals to true. Will it exclude all the false ones and include all the true ones if I do that? Will it exclude all the falses and include all the truths if I make it less than or equals to 2? No. Right, we have now this one. If I use it as is, that specific constraint is going to give me a 1, which is going to be included with less than or equals to 2. So I've got a problem. I'm including something that should not be there, meaning something's going to be allowed that should not be allowed. Right, so no, that's not going to work. Okay, so we say So let's try minus in between them. Okay, doesn't hurt to try. Let's see. So we say, okay, let's try minus. Okay. To include you guys, what is 1 minus 1 minus 1, 1 minus 1 minus 1? It will have the same effect, but before you say that, let's get the answers. 1 minus 1 is 0, minus 1 is minus 1. Thank you, Amandre. You can give me the next one. 1 minus 0 minus 0. 1. You can give me the next one. 1 minus 1 minus 0. 0. You can give me the next one. 1 minus 0 minus 1. 0. 0 minus 0 minus 0. And you've got a 0 minus 1 minus 1. That would be a minus 2, a 0 minus 1, and a 0 minus 1. So those would be, if you do or here, which all should be true. Okay. Is there anything I can do to include all the ones that are true and exclude all the ones that are false with some kind of right-hand side and sign? Is there something? Include all the truths, exclude the false. Let's see if you guys got this. Vian, if I make it less than or equal to 1 to 1, I've got this one on top that I said I'd rather have as true because we're focusing on it being adjacent. So in that case, if you made it false, then it would work. Let me see what else. Are we sure though? No, because of this one. Oopsie. So if you make it less than or equals to 1, that won't work because of that one. What about 0? Ah, yes, Danila. I was also now going with the 0 there. What about 0? So for this, all of these, they are included. The false would be, if you want to go with true, no. Amanda, it's not the final answer. I'm just saying if we take, yeah, if you want it to be true, then -1 would be included. But if you want it to be false, then it would not be included. So now let us decide which one we're going to go with. Because otherwise it's going to mess up our whole thing here if we don't decide. So we have to now make a decision. Right, so let me think quickly what would be the best with those two constraints that we have. Let me think. I'm just thinking that I missed something. No. True. I'm going to go with true because the main focus is adjacent. If you went with false, you saw now what could work. So I'm going to go with true there. Right, let's see. Let's see if we can do that. Right, now I'm going to start for again, just in case if someone lost me on that one. So I'm just going to start again just to explain. No, not that. Just to explain that piece. So include all the trues and exclude the false. Let's see. Right, so let's stick with true. Right. We do have other constraints, but I would rather go with this because I'm focusing specifically on it being adjacent. So if I wanted to, let's say, change it up, let's say later on, so I'm just thinking practically. So later on, someone would come and say, oh, okay, let's let them go to 3 provinces. Now, instead of changing all the adjacent constraints, which is going to be a lot of work, because remember, you have to do for every single province, you have to check what's adjacent. Instead of doing that, I just go here and change this. So I'd rather then keep them kind of separate to say, okay, I have those constraints that I can change easily, but when it comes to adjacent, I make sure that it's adjacent. So that if I change that, for example, to a 3, this should be true. Does that make sense? Then this must actually be a true. So I don't want to make that a false and then later on have to change all my adjacent constraints, which would be horrible. You're going to see how many we're going to have. There are 7 provinces. You have to do this for all 7 and for 2 different sales reps. So 7 times 2. And you have to check all those constraints again. So practicality and more efficiency, you're going to have to go with the true there. Okay. And I'll argue that. So advice there now. Go with true. Right. But you've learned something. That's what you're here for. So you've now learned something. So we're going to go with true. Let's see how that goes, though. So that should be true. Then we've got a false here that we don't want to include. That should be true. I just want to double check that everything is supposed to be what it should be. So true, we only have one that's false. Let me just make sure that we also did the subtraction right there. 1 minus 1 is 0 minus 1. Then we've got a 1 minus, then there's 1. 1 minus 1 is my brain 0. Then we've got 1 minus 0 minus 1. It's going to be 0. That's included. And then all of these, when you subtract something, it's going to be a 0. Right, let's see. You didn't have to multiply by 2. Are we sure? In the private chat, which false? Which false? We're saying that if it's this one that you're referring to, then we're saying that's false, because if you do not include one of them, then you're saying nothing is adjacent to A. We're checking specifically adjacent. So for the first one, if all 3 of them are chosen, yes, they're adjacent. If just this one and none of these, then we're saying, oh, okay, then we don't have anything adjacent. If it's these 2, yeah, it's adjacent. This one doesn't have to be chosen, but it's adjacent. Happy. These 2, this was not chosen, but these 2 are adjacent. We are happy. We at least have 2 of them adjacent. But when this one is 0, we don't care, because we're specifically looking about A being adjacent. All right. All right, let's see. So it works. So you'll have less than or equals 0. That would cover this true, cover this true, and this one. And just thinking if I missed something there. No, it would cover this true. It would cover this true. It would exclude this one, which is what we want. And it would include this one. So yeah, it would actually work. If we use less than or equals to 0. Okay, that's cool. So we've got a new constraint that's not even in the memo. Nice. Right. So guys, a tip that I saw from previous years. When you write a test, you're doing some of this on paper or on Excel. Please keep it. Like, don't go and delete it or throw the paper away. Remember, if you, let's say, get marked wrong because my memo didn't include that, you need to actually be able to prove to me that, okay, your solution also works. Right, remember I told you, come and argue, but in a nice way, but come and argue so that I can see whether it's true or not. I can obviously counter argue if I have something, but if I can't counter argue, or whoever is doing the query, then they'll check if we can give it to you. Right, so in this case, we have something else than what our memo has. So we have x11 minus x12 minus x13 less than or equals to 0. So if it works for all your constraints, yeah, then it works, right? Then you use it. If it works, it works, right? I'm just going to quickly give you a moment to take a screenshot of something before I show you that the 2 would also work if you were kind of pushed into multiplying something. I'm just giving you a second. And that was it. So that was me saying, we didn't do the 2 yet, we just said minus minus, and then we try them less than or equals to 0. So then you go and say, oh, it's x11 minus, x12 minus, x13, and then less than or equals to 0. And then that's then going to be your final form there. If you were forced to use it to, I'll show you that it will also work. So there are many ways to write these constraints, not too many, so we try to cater for everything, but if you miss something, please keep your workings so that you can argue it. Unless if I tell you, that shouldn't have been true, then obviously, oops. Right, but keep your workings, please, 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 so that if you see yours was not marked the same, you need to be able to argue your point, right? Remember, I went with true just purely on the fact that this constraint focuses on it being adjacent. Then let's try this one. Just want to show you that the answer in the memo also works. Otherwise, you're going to be like, why is it different? It also works. Okay. So sometimes you're forced to multiply with something because it doesn't matter if you minus or plus or minus. It does not include the truths and it does not exclude the falses. So then you're left with trying to multiply with something. Right? You never have to divide. If you multiply, it's fine. Right, so you multiply something, but you multiply it with everything because it's one single constraint. I'm going to start with minus just because minus is already there. Could have started with plus, minus, doesn't matter. All right, so we try and say, okay, how can this go? All right. So we say 2 times all of these. So I'll just do a quick different color there just to keep track. So 2 times 1 is 2. That's going to give 2, 2, 2, and anything here is going to give me a 0. So just to make it clear. Then we say, what is 2 minus 1 minus 1? Okay, that gives me a 0. 2 minus 0 minus 0 gives me a 2. 2 minus 1 minus 0, 1. 2 minus 0 minus 1, 1. 0 minus anything, so 0 minus 0 minus 0 is 0. 0 minus 1 minus 0 is minus 1. The other one around minus 1. 0 minus 1 minus 1 is minus 2. So just to show you that if you check all the truths, let me just highlight them. Is there a way to include them but exclude the false? So what can we use to include all the truths and exclude the false? Yeah, you always need to leave this question for, well, not the whole question, just the logical constraints for last, so that you have some time to spend on them. I think I did give that advice before. If I haven't, do your algorithms first so that you have time to spend on these constraints. But anyway, do I have something to include all the truths and exclude the false? Yes, I do. So if I use less than or equals to, let me ask you guys, what? Less than or equals to what? What will include all the truths and exclude the false? One, very good. I'm not sure, Caitlin, probably. I don't know. I'm not the one setting it, so I don't know. But probably. Less than or equals to 1, perfectly fine. It includes this one, includes this one, this one, this one, this one, this one, all the truths, this one, all of them are included, but the 2 there will not be included. Right. So that would work. So if you were to write this, it would be 2x11 minus x12 minus x13 less than or equals to 1. So that would also work. Now for the sad part, you have to do this literally for every single one of them. So you'll even have the same constraint, but for sales rep 2, province 1. Sales rep 2, province 2. Sales rep 2, province 3. Exact same constraint for this one though, because it worked for that, for sales rep 2 as well. So you're literally copying and pasting and giving marks on that one if you got the first one correct, of course. Now let's go back here. What about province B? Which ones are adjacent? Province B, which ones are adjacent? Perfect. 1, 3, 4, and 5. 1 is A, 3 is C, 4 is D, 5 is E. They're all adjacent. So let's try this one. It's going to be one hell of a check. But when you set up that first constraint, it will stay very much similar because it's the same idea. It's just going to be maybe something that you need to multiply, which would have worked with this one without multiplying, but with the bigger one, it maybe might not work. All right, so let's see. I'm going to focus on B, sales rep 1. Guys, don't make yourself negative. If you make yourself negative, it is not going to go well. Like, talk about rather positive things like you're practicing. So if you just keep on trying and logically reason it out, it would go well. Like if you put your mindset negative, it's not going to go well. Because as soon as you see the question, you're going to feel negative. Right, so do not do that to yourself. And also don't make my day negative as well. Keep the chats positive, please. Make jokes are fine, but come on, please. Right, okay. Anika, very, very good question. We're not at that part yet, but very good question. We need to have constraints to make sure they don't cover the same area. Very good. Right, but yeah, we'll get there very soon. But I'm glad it popped into your head. That's awesome. Like if that's coming up, you have something to be positive of. Right. So let's see. Let's try B. So B is adjacent to, so Caitlin, you said 1, 3, 4, and 5, and I totally agreed with that. Okay, so let's see how we can deal with that. Okay, but B included though, but B is then 2. So all of those are dependent on B. So I always write the one that they're dependent on here on the side so that I know if I need to multiply something, it will probably be on this one. Let's still focus on sales rep 1. What are the other variables? It's still sales rep 1. So 1 and 1, 1 and 3, 1 and 4. 1 and 5. All right, just to make it clear where that comes from. All right. So we're going to say, okay, how do we deal with that? All right, let's first start with checking some conditions. But hint, hint, the signs will probably be the same. So in between, that will probably be minus for all of them as well, except for the one that they are dependent on. Okay. So remember, it's or, but based on that one. Okay, so going back here, let's see. With something like, let's start with zeros. Like this be fine if we look at it as being adjacent. Is there anything adjacent right now? No, so false. If anything has a 1 and the rest zeros, then we're looking at something being adjacent, at least 2 of them. So what do you think? True or false? True, very good. All right, so anything with a 1 there, with the rest being zeros, we want true. You can have a bunch of them. I mean, you're going to have like this and like this, but each of them must be, let me just write it a bit more down. Each of them must be true. So you'll have a true, true, true. Okay, but the values when you do your calculations will be exactly the same. I mean, it's still 1, 1 with rest zeros. So just to make it clear, then I'll erase even that one, another true. It's the same, just different combinations. But when you do the calculation of the minuses, or even multiply something in front, it will have the same values. So I'm going to say, instead of writing all of that out, I mean, why punish yourself? You can. I'm not saying you shouldn't. I'm just saying instead of doing that, you can say one of these is a 1. All of those should be true. Okay. Now, if this one is a 0, am I going to limit anything else? The way I'm asking, you probably have the answer. But am I going to limit anything else? No, because we're focusing specifically on what is adjacent to B. So we're not limiting anything else. So it doesn't matter what we have here for any of these. Doesn't matter. It should be true because we should not limit anything else. Because we're not looking at anything else right now. We're looking at adjacent to B and sales rep 1. Okay, so let's see what we can do, right? So if I work with it with minus in between them just as is, and that one is a positive, which they're dependent on. Let's see if we can do something with that. So 1 minus 0, 0, 0, 0, 0, so that's going to be a 1 there. Right. Oh, thank you, Vian. I almost missed the most, well, not the most important, but one of them that might make a big difference. Thank you, Vian. We also need the 1, 1, 1, 1, 1, 1, 1. So all of them, they say all of them 1, as well as 1 and 2 of them being a 1. And then I need a 1 with 3 of them being a 1. And we already have the 1 of these. A lot of combinations. Right, but as soon as it's adjacent, yes, 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 yes. All right, doesn't matter if it's 2 of them or 3 of them or all of them, it's adjacent. Please allow it. All right. Reason being, if we change our constraints, we have these already set up just for adjacent purposes. So we can go back and just change the constraints in terms of how many should they cover. It makes it easier to modify. All right, let's see. Thank you for that, Via. So 1 minus 1, 1 minus 0, 0, 0, 0, 0 stays 1. 1 minus 1, doesn't matter for which one. 1 minus 1 is going to give us a 0 there. 0 minus zeros, it's going to be a 0. 0 minus any one of them, it's going to be a minus 1. 0 minus 2 of them, minus 2. 0 minus 3 of them, and 0 minus 4 of them. So all of this is specifically for that true. Let me do then a different color for the next one, just to show you the idea. For the next one, oh, it's not necessary. We can stick to red. Never mind. 1 minus 1 minus 1 minus 1, because I'm saying all of them are 1. 1 minus 1 minus 1 minus 1. So I'm just saying it's all of them, so that's going to be a minus 3. If it's 1 minus 2 of them, we don't say which 2, it's just combinations. Which 2 of them? It's going to be 1 minus 1, 0 minus 1. So it's going to be a, my brain went now bloop, minus 1. 1 minus 3 of them, so it's literally 3 of them. That's going to be 1. We don't know which combinations because it doesn't matter. It's the same calculation. 1 minus 1 minus 1 minus 1 is going to be minus 2. Okay. Is there a way of including all the trues and excluding the false? The 0 or 1 just means it doesn't matter if this is 0 or 1, or if this is 0 or 1. So meaning it could have been 0, 1, 0, 1, 1, 0. Doesn't matter what these are going to be. All of them are going to be true because we're not looking at any of the other adjacent ones. We're looking specifically adjacent to B. So if B is not selected, well, any of these must be allowed. Doesn't matter what. Okay. So I'm just not going to write it out step by step. That's going to take forever. All right. Okay, then going back there, let's see. We've got here a false that we don't want to include. So we'll... Yeah, we can use less than or equals to. Just want to make sure you say 0. Good. So if we use less than or equals to 0, that's included, 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 included. All the trues are included, and the false is excluded. So you can simply go with x12 minus x11 minus x13 minus x14 minus x15 less than or equals to 0. Perfect. If you want to use that formula thing with what's the upper value, like that location one, then you'll use, in this case, multiplying by a 4, because 4 of them are dependent on that one. And then you can still set up a constraint that could work. So I'm just saying there are multiple ways, like in the memorandum where we actually multiplied something. But this works for all our conditions, so it's okay. If it works, it works. Right. Yeah, this is less complex, but you have to make sure it works. So the only tricky part with these are the rest of the constraints will follow the same kind of thing. So like a minus and a minus, minus, minus in the middle of all the rest that are dependent. But you can't be sure without testing, though. But we tested now 2 of them, so the same principle will apply to the rest of them. So at least test one with, let's say, only 2 of them adjacent, and then test one that's a lot of them adjacent, and make sure it still looks like the same constraint, just different variables. Then you can apply exactly the same thing for literally all of them. So if I look at adjacent from F quickly, adjacent from F would be D, E, and G. So I'll have F as the main member. Then I'll have D, E, and G also. Then I know, okay, I'm subtracting D, E, and G. F is positive because that's the main adjacent checking. And then I use less than or equal to 0 because they're all going to now follow the same format because it's the same principle for each of them. It's the same type of constraints. Right. If you don't have that, you will literally have to. I don't think you can create a constraint. You can try though, but then when you set this up, I'm just going to use green quickly. So you can try, but then you're going to literally have to go and say, okay, something like this is true, but if I have something like, let's take this one, this one, this one, this one, where it's all of them false. When it's one and more than 2 of them, so one and another, so let's say this and this, that's false. Because now we're specifically looking at making sure it's 2 every time. So this would also be false because we're specifically looking at they have to go to 2. Right, and what if someone said now to you, we didn't say must, like in they must go to 2. They could go to 3 or 4. Like, remember when we started, you asked, but can't it be greater than or equals to 2? Yeah, then you have to change all of these constraints. Right, so then you have to go literally to all of these and say, okay, now all of them are now true again. So you're going back to what we did originally. Right, but setting up the constraint, yeah, you can set it up. It's just not a very efficient way because, like I said, if you go and just change literally the fact of we don't want it to be equal to 2, then you have to go and change this constraint for all of them. And if, let's say, you have that 40 constraints, it follows the same principle, but you have to literally go and change each and every one of them, go back to solving the canonical form from scratch, whereas you would have just changed 2 constraints instead of all of those. But it will work. I'm not saying it won't work. I'm just saying it's not a great idea. It's not as efficient, but it will work. I mean, these are all about your own logic. So it will work. Okay. I hope that's okay. But yeah, then all of them will be false, 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 except for the ones that would be only 2 of them. So like this one, 2 of them. If I had these 2 of them should be true. So that would, yeah, you can set up a constraint, because then you'll have maybe 1 minus 1, 0, 0 for all the truths, and the rest are false. So yeah, would work, could work. Not the best, but could work. Then Anika brought up something very important. Yeah, we're checking adjacent for each. Yeah, sure, that's great, but how do we make sure they don't go to the same places? I mean, do you really want them to go to the same places? Because, yeah. So technically, you're trying to maximize the number of students. So it will try to make the sales reps go to different places. But we'd rather have constraints to make sure that it does not happen. Remember, if you're solving this with any algorithm, you don't know what's going to happen in that algorithm. You want it to just solve and get it done with and not think. So it's an algorithm that does not think for you. So you need to have all the constraints there to make sure something that should not happen cannot happen. So meaning I don't want sales rep 1 to go to A and B, as well as sales rep 2 going from B and D. Because then province B is going to happen again or be visited again, same students. And if you don't put the constraints, I mean, a system will not notice that, oh, okay, this is the same province. It's just a number, right? So just to make it clear, if you go and say A and B, and let's take C. Let's take sales rep 1 for this one, and then you say sales rep 2 for this one and this one. Even though your variables are specific to say, okay, this is X 2, 2, and this is X 2, 3, and this is X 1, 1, and this is X 1, 2. Yeah, they're specific, but there's nowhere specifying that this cannot happen. So what's going to happen in your objective when you scroll up? So in your objective, I went way too far up, and now my mouse is a bit weirdly. So in your objective, it's going to go to those values. Yeah, those values and say, this is a 1, this is a 1, this is a 1, and the other one is a 1, and just simply add everything up. There's no check to say, oh, okay, but sorry, I wrote the wrong one. This is the 1, and that is the 1, these 2. So there's no check of saying that, oh, okay, these are actually the same province. No, it just sees it as, oh, I've got a nice 21, 29, and a 29. If I add the biggest values together, I'm going to get the most. But it's the same student. The system or this IP is just an IP that you're going to put in a system, and the system won't know that they're the same. It's purely just going to see the numbers and be like, I take the biggest numbers. Whether I take it again, it doesn't care. So, Henry, you had a good idea there, a very good idea. I don't know why you deleted it. Very good idea. How do we set up constraints to make this happen? So we make sure that if, let's say, it's province A, we make sure that between sales rep 1, so I'm just going to say sales rep 1, SR1, and sales rep 2, they should not go to the same one. So if it's sales rep 1, province 1, and sales rep 2, province 1, if I check the ones there, I don't want that to happen. So that must be a false. If I make them both 0, I don't care if they're not going to those, they can go to other places. That's fine. If I make this, that's what I want. If I make this, that's what I want. I want them to only one of the sales rep to go to that place. Then you set up your constraint. So like Henry did there, so you can go plus in the middle for all of them. Then it becomes a 2, a 0, a 1, and a 1. If I include all the truths, it's going to be less than or equal to 1, and it excludes the false. So that x11 plus x21 less than or equal to 1 is perfect, Henry. All right, and you'll do that for every province. So province B will then be x 1, 2, and 2, 2 less than or equal to 1. Province C, 1, 3, 2, 3 less than or equal to 1, just for every single province to make sure that they don't go to the same province. All right. So Annika, I hope that answered that piece where you're like, oh, okay, I need to make sure that they don't go to the same place. And yes, you do. A system that will solve this IP will not know that they're the same provinces. So you have to have constraints for that. Very well done on that. Right. Before we do anything else, but that is basically it for this one. Before we do the knapsack exercise, which I'll start with slow, and then the rest I'll just say, okay, well, you've got the memo. So that we can get to after break the review. Let me just ask for, let's say, 5 minutes just to grab some water or something. So just 5 minutes. Just give me 5 minutes, and you can also take 5 minutes. I see some of you asking me about the test, guys. I do not know what's going to be in the test, what it's going to look like. So I have no idea. I can't give you any hope there. Right. I can give you hope with, we normally ask things very similar, not exactly. Please do not tell me this was not in a test. Similar to exercises and classwork, so we don't go all out. If we do, it's not going to make you fail, unless if you, of course, didn't do anything else well, right? But if you, how can I say, practice and you do the algorithms and you're okay, you should make it without those. So if we make something really difficult with logical constraints, But we stick to exercises and stuff. Similar, not exactly, I said, you heard me, not exactly, but similar. So make sure you do exercises, work with other students to make sure you set it up correctly, or your logic makes sense at least. Let me go with that. Right. I did kind of try doing that. You already have some Excel sheets, and wherever I did put some explanations, I did put some explanations. I'm not going to do it for every single exercise. I told you guys I will not do that. You need to then send me your work and then ask. But here I literally tried to give some comments to explain what was done where, what I tested. All right, so I already did for some where I felt it's difficult. I mean, there's more. Right. Right. So continuing from there, let's see, knapsack. I want to just think which one quickly. I think the stocks and bonds one is a nice one. Yeah, let's tackle this one. I'll start it with you, show you a few of them, and then from there, you can just check the solution there. Right. But step by step, no. I mean, it's the purpose of you attending class is very important. Hey, like, I know he's very specific, but for me, it feels like I don't want to waste my time teaching you if you're not going to listen anyway. Recordings are fine if they are, but I don't think they are. But attend my class, make your notes, and ask when necessary. So that's just my teaching style, sorry. Right, but where I thought topics were difficult, I gave some worked examples there and some tips and things that I explained where I felt necessary. Other stuff I don't feel is necessary because if you're in class, you should be okay. All right, just these topics that's a bit difficult. The other stuff is just literally steps. If you feel like there's a specific topic, you know what the name of the topic is, go search for that topic, go search for examples, go search. I mean, use resources. Don't just bargain on us giving you everything. Right. The whole purpose is for you to get to a stage where you're basically on your own, okay, right? Because someone else will not hold your hand next year. Yeah, even ChatGPT, but obviously don't trust it with everything. I'm sure you guys saw already that not everything. Please don't trust it with everything. But yeah, use it to help you. I mean, it's there. It's a tool. It's a resource. Use it to help you. Use it to help you find information. Use it for explanations, yes. But just always check the answer if it matches mine, for example, so that you can really know if you should be trusting it, you know. But yeah, if it gives you correct answers, for example, then you can use its explanations, right? But yeah, use it, please. Any resources, use it. Help yourself, right? But I think I've done more than enough to help. Okay. If you, however, have a question about something and you can show me worked examples, you're more than welcome to send me that on Teams. I mean, I helped a few students just yesterday with some stuff. And if I don't get to you before the test because you send it to me late night, then that's not my problem, to be honest. But if you send it during the day and I get a chance to quickly help, I'll definitely help. I'll always help if I have time to help. All right. But I want to see that you put in the effort and you're not just waiting for me to give you everything. So that's the point. All right, going on before I just talk and talk and talk. Let's get back to knapsack. So this one right here, I just want to quickly go through. The IP itself, setting it up, that's up to you. I mean, you know, knapsack should have one objective function, one constraint. Yes, there are other variations, but for the scope of this course. All right. So we also normally focus on knapsack being a max problem with some kind of less than or equals to constraint, because you're normally maximizing the worth while trying to fit everything into a bag with some limitation. So that's normally what we focus on with knapsack. So I just made sure, even though we normally do not ask a min, I just wanted to make sure so that you have that information. If you were working with a min, you would work with a greater than or equals to sign. That's it. Like, don't, it won't work. Well, it won't work well the other way around. But anyway, so if you would work with a min and a greater than or equals to sign, you'll still do your whole ranking table with Z over C, except, so I think Armandre was the one, maybe, I can't remember who specified this and be like, would it then be smallest to largest? Yes, it will. Smallest rank, smallest to largest. How did we rank the max problem? Who remembers? Oh, okay. Who remembers? How do we rank our table? We get our Z over C values, then how do we rank? From smallest to largest or largest to smallest? Yes, perfect. So largest to smallest. You should just say large or small. Right, so please take note of that. Although we mostly ask max because that's what knapsack usually refers to. Usually. Oh. No, it's understandable. Right, if you do have internet issues every now and then, just ask. I'm sure there's someone who would help wherever. But that's why I do exercises as well, to just help. If, let's say, you miss something, at least you have something else to help you a bit, right? That's why I made it the study guide, so that exercises are like part of the course, if that makes sense. So that if you miss something, at least there's something else to make up for it. But yeah, that part there, just stick to it a little bit longer than I should, just to open it for a little bit longer, just in case someone missed it. So I'm going to quickly write it out so that we've got our beautiful IP there. Just want to scroll down, not too much, but I don't see this. There we go. All right. So we're going to have our max Z. So I'll write this Z so that we can keep track. That's our Z or Z values. Then for our constraint, subject to, that's a 5, x1. And then that one, less than or equals to 14. Okay, we're ready to start. All right, let me just zoom in a bit for the half-blind people, right? Even though it was not me saying anything. Okay, let's see. So for our ranking table, we start and we say, okay, which item? So we're going to have x1. Yeah, if you admit it, it's fine. So let's do this, and then let's see. So it's always your Zi over Ci, so it's going to be 16 over 5. If I ask for fractions, that's what I'm expecting. 22 over 7. If we ask you to simplify, please do. Remember, instructions are important. If we want to see something, we ask for it. All right. Let's see. Okay, decimal values we'll write just so that we can see what they are actually, because not everyone is so 100% of seeing a fraction and being like, oh yeah, that's that. All right, so this one is it's on the dot, 3.2 actually, not approximate. Then we've got the next one, which will round a bit, so approximately 3.143. I'm not rounding specifically because I just want to see the values. That's equals to 3. I don't know why I had to think about that. And then the next one, approximately 2.6667. Okay, now from large to small, it's a max problem. So we identify the largest to the smallest, which would then be x1. Oh, it's nice. x1 to be the first one is a very nice one. Hi. This one is really nice. See, even Anika's like, nice, because you're literally going in that order. So it's literally 1, 2, 3, 4. Row 1, 2, 3, 4. Large, but please, large to small. Don't just go in a test and be like, oh, it was 1, 2, 3, 4. No. Please, large to small. Okay. I don't know why that erased. There we go. So please, it's not 1, 2, 3, 4 just because that's item 1, 2, 4. Okay. Otherwise, you'll get 0 in the test. Or if you're lucky, maybe 1 or 2 marks. So please don't do that. Okay, now going on. So in subproblem 0, or just the original initial table, if you want to call it a table, but I'll say sub-0 for those fans, if you know what I'm talking about. Mortal Kombat fans. So there's a sub-0. Then we go on and we say, okay, x1, x2, x3, x4. Let's see what we need. Right, starting with x1. What is the value of our constraints? I'm just going to highlight there. It is 14. Do I have enough? I haven't done anything yet. Do I have enough for x1 to go in the bag? Or in this case, for the investment to take place? But do I have enough? Just want to make sure it's not my internet. Okay, cool. Sure. Thank you, Via. So we have enough. We put it in the bag or invest. Right. So then we go and say, okay, out of that, it's now 5 less than it used to be. So I've got a 9 left. Now I go check x2. Do we have enough for x2? Yes, 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 yes. So we put it in the bag. We say 9 minus 7. We get it 2. For x3, do we have enough? No. x3 needs 4. We only have 2 left. So it's going to be 2 out of 4. That's a big no. Right, remember, read very carefully. If they just say fraction, you can leave it like that. We want to see what's left over, what was actually needed. Right, unless if I say simplify, then you give me 1 over 2. Right. Oh, 3. Oh, okay, never mind. So then x4, was x4 used at all or invested in? No. So that's definitely a 0. Definitely. Right, let's see, sub 1 and sub 2. So if these, let's see, one of them is going to be equals to 0 and one of them is going to be equals to 1. Which one? Which one am I branching? Although it should be clear, but which one am I branching? x3, perfect. That fraction shows me that it's x3. All right. Usually then let's say something you program, you will write it for the value that gets a fraction that will branch. That's why we keep on doing that. So yes, Nandipa, we have our first conflict. So we're going to make x3 equals 0 or x3 equals 1. Then we go and do something to just show that this is forced. So later on, we keep it that way. So let me just do, I thought about making the other colors. I'm having fun with this notepad journal thing. Okay, going on. So for sub 1, we know x3 is 0, so we don't look at x3 again. So we go again with x1, and we say, can I put it in a bag? Yes. From 14, it's minus 5 equals 9. I'm just using it from the top there. Then we go x2. Yes, it worked. It put it in the bag. 9 minus 7 equals 2. But now we're skipping x3 because x3 is a definite 0. So we go to the next one, which is in our ranking table, x4. I'm just going to continue saying ranking table so you realize that this table is important. We're not going from 1 to 4 because of the order. We're using a rank order, okay? So then we go and say, okay, x4 is our next one. Do we have enough for x4? Let's go up. Who remembers? No! So sad. We need 3. So we check what's left. 2 is left. So like Henry said there, you've got 2 over 3. So we can't fill it in. Okay, we can't do this investment. So for this specific one, we're going to branch further. Okay, so this one. On the other side, let's check what will happen there. So on the other side, we're going to go and say x3 equals 1 is a definite. So I take my 14 and I start with that one because that's definite. So whichever ones you are forcing, that's definite. That you have to do first. So x3 is going to be the value of 4. So I subtract that 4 there. Just to show that's where it comes from. Right, so now I go and say, okay, what's left? 10. Back to our ranking table. All right, so remember it's large to small. It's not always 1 to 4. I'm just going to reiterate that. So now we go back and we say, okay, which is the next item? x1. All right, so x1. How much does x1 require? 5. Do I have enough? Yes. So we put it in, we invest, and then we say, okay, it's 10 minus 5 equals 5. Guys, if I ask you for answers in this question, I'm looking for these ones and zeros, not the minus stuff. The minus stuff is your calculation to check if it could be a 1 or a 0 or a fraction. Right. Those are extra. I'm looking for what is it going to be a 1? Is it going to be a 0? Or is it going to be a 2 over 3, for example? Right, then the next one, I don't know why that happened. x2, we go check. We have 5 left. So for x2, we require, let's see, how much? 7. Do we have enough? Thank you, Adrian. We've got 5 over 7 because we don't have enough. Is there anything for x4? What do we put at x4? No, we put a 0. Very good. So that one will branch in to x2. All right. So I'll show you the next two, just one of them, and then after that you'll be able to follow the example. So let's go from sub 1. So sub 1 will go to sub problem 1.1 and sub problem 1.2. This one would go to 2.1 and 2.2. All right. Now on the left, we now specifically focus on x4. But what should we have also forced? Yes, Nandipa, we want fractions for those that should be branched, yes. Not 0, 1, because we want to see that you're still going to branch on that one. Zero. Why did I write it that side? x4 equals 1. Yes, so from the previous one, we had x3 equals 0 from subproblem 1. So x3 equals 0 is going to be for both of them a definite. I normally make a little star just to show that these are definite. There's no choice. No choice. Right, so if something is then not working out, then it's infeasible. Right, on the other side, you would go and say, okay, what is being pivoted on now? x2. So I'm either going to have a 0 or a 1. And then I check what was branched on and what was forced before. So what am I forcing now again? You tell me. What am I forcing now again? Very good. X3 equals 1 because it comes from that one where X3 was forced to be 1. So you keep it to force it. Okay, and then you just go to the next. So you go back to your ranking table. Every time you're done checking the force values, you go back to your ranking table. So here it was 14 minus nothing. 14 minus nothing. So it stays 14, 14. Now we go back to a ranking table, which we know by now is X1 next. X1 we know needs only, let me scroll up, 5, and X2 only needs 7. So if I use 5 here for this one, and I'm going to be left with 9. So X2 is also possible. I put it in. I can say 9 minus 7, but yeah, it can go in. That's the value I'm looking for. Do we have leftovers? Yes. But can we continue with this one? No. Right, there's no more items to put in. We forced what we forced. The ones that are not forced can go in. Yes, we are on candidate A or CA. Then, only then I want a Z. Only then, hint, hint for the assignment. Only then, because why would you want to calculate the Z if it's not optimal? It's now optimal. So I go up and I say, okay, which ones? Okay, so this is X1 and X2 that are ones, the rest are zeros. So 1, 1, 0, 0. What is the Z value? What's 16 plus 22? 38. Yes. Very good. So the first one is 38. All right, then you'll do the other side where you're going to say, okay, that is minus nothing. So you still have 14 left. And then we go say, oh, but X4 must be a 1. Okay, what's X4? X4 is the value of 3 in the constraint because that's what I'm limiting, right? So 3. So 14 minus a 3 there, and I have 11 left. Then we go to the next one. We go back to the ranking table, but I already know it's X1. Okay, do I have enough for X1? Go back up. Do I have enough for X1? Yes, I do. So we're not looking at the Z until we have an optimal table, right? But yes, 5, perfect. We have enough. So we put it in, we say, okay, and we go and say 11 minus 5. So we left 6 there. Right. Next, X2. How much do we need for X2? Who remembers? But I'll scroll if you like. Okay, you guys know. 7. Do I have enough? Okay, sadly. Sadly, no. 6 is what I have. 7 is what I need. So this one is going to go. Yes, another one. So this one's going to be subproblem 1.2.1. Subproblem 1.2. 0.2. Okay. Guys, this you can do on your own. So I'm not going to go there, but I'll just make a note. Do further. Right? Now let's go on the left here just to show the whole branching idea. So on this one, what am I branching on now? What's my focus now? With X2 and without X2. Perfect. We're going to have one without and one with. Perfect, perfect, perfect. What did I force before? There's more than one thing. Good. Remember, we come from this branch. So it means we are actually still forcing the same things. Very good. X3 and X4 will stay as they were from the previous branch. So that X3 equals 0. It's going to be x3 equals 0 still for both of them. The x4 equals 1 will stay x4 equals 1 for both of them. So that's why I make stars, so I don't have to go scroll all the way up and see what was previous. Right. Now let's see on this one. Okay, 14 minus nothing, 14 minus nothing, 14 minus. So x4, just scroll up a bit. My mouse didn't scroll so far. x4 is a 3. Right, so we minus our 3, we're left with an 11. What's the only variable left here for this one? The only variable. x1. How much did x1 need? 5, very good. So x1 needed 5. We have 11 left, so yes. I was wondering, Henry, I'm like, wait, what? Okay, that makes more sense. Okay, so we do not have any items left, so we've got CB. Give me the Z value of CB. We only have x4 equals 1 and x1 equals 1. x4 equals 1 and x1 equals 1. So like that. Twenty-four. 24. Yeah, 24. 24. I don't know if they wrote this stuff a different way around in the memo, but just check. I think this one, they made a typo there. It should be 24. All right, so just make a note here to check this one. I think they made a mistake there, but it's still not the best, so it wouldn't make a difference, but 24. All right, but don't doubt yourself. I mean, you know the Z values, add the correct Z values. Thank you. Right. Other side, we've got x2, so we go and say, okay, how much do we need for x2? So we go up to our constraint, x2 requires 7. Okay, minus 7. We have 7 left. Next one, 7 minus nothing. Okay. Next one, 7. Oh, 7 minus, then we go check x4 needs 3. So we have 4 left. The last one that we have left is still x1 for this one as well. Do we have enough for x1? No, we need 5. We only have 4. 4 over 5. Perfect. So this one goes on. Okay. So it's literally the last item, guys. So even though you're doing another one, you're going to stop here because you already forced 3. So you can only force one more thing. Okay, so thank goodness. If you had more variables, yeah, that can go on. Right, but what are you forcing? Let's see if you guys got this. Which variables are you forcing and what are you forcing them to be? For both of them. We're forcing x3 equals 0, yes. We're forcing x4 equals 1, yes. On both. And x2 equals 1, yes. And what are we forcing now? x1 equals 0 or 1, perfect. All right, so we're forcing literally everything, but what stays the same? All of these, because that comes from the previous branch. All right, one is going to be infeasible, and the other one is going to be CC, which is x2 and x4. What is the Z value of x2 and x4? So x2 and x4. Z value of, yes, 30. All right, so we've got another candidate. So far, which candidate is so far the best? 38, 24, or 30? Which one so far? Yes, 38. It's a max problem, so the largest. Very good. Obviously, do that further, but you saw now everything you needed to see. All right. Let's quickly take a 15 minutes, well, 16 minutes, and then we'll go through the review. All right, see you after break. So knapsack closing that one. Then I've got this one. Which I'll quickly discuss. Some pointers, some things to check, but other than that, you should be able to go through the review when it's open, work your way through it, like do it again, like as a practice, and then see if you can get to the correct answers. Yeah. Danilo, yeah, as long as it's .NET. I think it's specified .NET based. Yeah, joke, yes. Then anything with that, yes. We'll go to assessment queue quickly. Yes, give me a minute. I am still here. I'm just opening something. Let's see. For this one, do you want to see if there's a different way opening it? PR3. Right. Okay, so there's that one. Because there's one. Let's see. Just always check if there's not an instruction maybe specifying what you should do. If the question does not specify, instructions are very specific. Now with this one, we gave you 2 tables, but when you solve, it's still going to be 1 table. And the reason for this is you could actually combine these tables into one. And the reason is you want to minimize the total time it takes to complete assassinations. Now, the total time is actually these 2 given tables that I can combine into one to get the total time. We gave you a bit of a hint in class. So you'll see here the first table is specifically for the execution, and the other table is specifically for the planning. But to get the total time, you had to just add these 2 tables together. So, for example, Winter Soldier and Captain America, the time there for planning is 7 in times of days, so 7 days, and the time for execution is also 7. So to get the total time in terms of days, it would be 7 plus 7, which is 14 days. And you would have to do that for literally each and every single one of them to get a new initial table. So these 2 were what you were given, and you had to literally go and sum up the positional values for that. Right, then you would have had to fill in that other table. Then we also gave you that side note. Read the fine print. We told you what is possible and what is not possible. So you'll see here that we specified each of the assassins take a specific time, but the Winter Soldier can only conduct 1 assassination. So for this specific row, it can only have 1 for Winter Soldier. Okay. Maybe I can write it already there on the thing. So for Winter Soldier, in the end, when we have our final table, Winter Soldier can only do, let me write it here. I'm going to copy this table. Values, and just delete all of this. So Winter Soldier can only do 1. All right, we'll still think about less than or whatever. Okay, then Bullseye. Let's see what they say about Bullseye. Bullseye and Kingpin can assassinate 2 targets. Okay. So if I look at without the dummy, remember we don't have the dummy when setting up the IP. If I look at this being a 2 and this being a 2, should I say equals or less than or equals to or greater than or equals to? What do you think? What do you remember? They can. So less equals, yes, they can. Doesn't mean they have to take 2 targets. They can. Can they do more than 2? No, they just can do 2. So 2 or less is perfectly fine. Then that kind of forces me for this one to make it an equals to 1. Because if I give each of them 2, well, even if they had only 1, we have more people to assassinate than assassination. What do we call them? Assassins. Right, so we have more people to assassinate than assassins. So if I do not make Winter Soldier equals to 1, Winter Soldier will not do anything. So we have to then force Winter Soldier to do something. Right, so that one must be equals, the others must be less than or equals to. Right. Okay, so for that part, there we go. Let's see what else. Each member of the shield can only be assassinated by 1 Hydra assassin. Okay, so if we look at it the other way around, only by 1. Am I going to make it equals or less than or equals to? Or greater than or equals to, if you really want to go there? What do you think? What do you remember? Don't look at the answers. Equals. Right. We have to have the assassinations done, and we do have enough people to do the assassinations purely based off of this. I mean, if Bullseye takes 2 and Kingpin takes 2 and Winter Soldier takes 1, total of 5 people can be assassinated. I only need to assassinate 4. So there are enough. Yes. So we make it equals to make sure that everyone gets assassinated. They're not going to be assassinated twice, so that could have been logically, but equals to 1, right? But maybe you could have had a teamwork thing, dynamic, and then we make it say something. But they said assume only 1, so we're happy. All right, and then the additional travel thing. Winter Soldier cannot assassinate Nick Fury. So even if these values were able to be added, it's quite pointless. No, that should not be possible. Okay, no. And I told you dashes, you keep dash throughout the whole calculation. Okay. All right. Now, guys, if remember I told you in class, do not leave blank blocks. That I won't consider even. Like if you left a blank block, that's a no. Right, we did give you an instruction. But if you said not applicable, but just like instead of that, you would have said something like x11, x maybe 1,3, and x14, and then you said not applicable. That's not a train smash. You can let me know about that. But if you didn't say not applicable, don't ask me. I don't take blank blocks. We have given an instruction. Okay, follow the instruction. But if the order was changed, I do not see a big problem, even though we're normally very strict with instructions. it's still the same thing. So I'll consider it. Don't say I'm going to necessarily give it. I'll consider it. But you need to let me know. Otherwise, I can't consider it. Right? If no one did it, then I'm not going to worry about it. So that's just for that one. And the other constraint, which would have been this way around. So that would have been 1, 2, which would have been left out as a not applicable. And then the next one would have been 2, 2, and 3, 2. Right, so if you move the NA somewhere else, but it's still exactly the same, it's okay. At least you did fill in, maybe just not completely understand. But if you left it not applicable and you just left it blank, that's a no from me, right? Because I want to know, why did you leave it blank? Like, why? And don't tell me now. It's after the test. It's too late now. Right. I can't assume. Now from there, you set up your constraints like you normally do, equals, and that would have been equals 1. For these would have been less than or equals 2, like you normally do. This is x1, 1, this is x1, 2, this is x1, 3, etc. Quick question, would we have the dummy in the IP? Would we have the dummy in the IP? Are you sure? Later on, but not in IP. So IP is purely to solve Branch-Bound simplex. There's no making the matrix square with Branch-Bound simplex. So with that, you purely just go and say, I don't need a dummy. I set it up with what I have. But if you do Hungarian, you need to make it square. So then you need the dummy. Okay. As in the test, I called it John Doe. If you didn't know why John Doe was there, then you know now that you should have added a dummy. If you added a dummy, you know why John Doe was there. Right, so filling in the gaps, yes, okay. Filling in this, so follow the same, fill in the initial tables before reductions. So basically, what is your initial table that you're going to work with when doing everything? You'll see the dummy is also included. So you have to then go and add your dummy. Which value, before I scroll up, would you include for the dummy? You don't have to give the specific value, but like, what do we look at for the dummy? Guys, you'll still have time to go through your own test afterwards, so rather focus on checking first and kind of recapping or revising. Highest value, perfect, highest value. So when you add your two tables together, you check for the highest value, which is 55, and you add that throughout for your dummy. It's just not a column like last time in the exercises, it's now a row. Okay, what's first, column or row reduction? What's first, column or row reduction? Perfect, row, it's always row by column. So here they specify, fill in the matrix you found on which you need to do the first conditional check. You can't do the check until you did row and column reduction. So we need to now first do row and column reduction, row first, to not swap them. So what you would have done is you would have checked, okay, from this initial table, I go row first. Okay, row first. First row, smallest value, 14. I subtract it from everything in that row. Next row, smallest value, 25. Subtract it from everything. Next one, 14. Subtract from everything. Next one, well, that's a nice one. Subtracted from everything. So you're left of all zeros. Okay, now if you're left of all zeros, would column reduction make any difference? Only if you're left of zeros in every column, but would it make a difference? Would column reduction make any difference? No. Perfect. So even though you've learned how to use the zeros, it doesn't exclude the zeros, right? You still check column reduction. You check what's the smallest value, 0, smallest value, 0, smallest value, 0, smallest value, 0. So it would not change. If there were a smallest value, then it would change. All right. Don't know why that happened. Okay, now we have our table that we can do the conditional check on, right? After column reduction, even though it didn't change. Now we can do our conditional check. So that's what you now fill in. Okay, so now you're going to say, okay, how many lines can I draw? Remember the least amount of lines to cover all the zeros. So you could have gone with this one first because that was the most zeros to cover. Now from here, if you went like this, that's incorrect because that's not the least amount of lines. No. Right, so the way that you had to go was literally like this or like this. Okay. But if I go like this, I'm going to cover the smallest value there. So just make sure. Oh, I should have included that in the memo, but I didn't. Just make sure that if you went this route and still got the same answer, it's still okay for that one table. This one. Let me just show you which one. Question 1.2c. Right. Just check that table because that might have been you just crossing a different line. I should have taken care of that, but I'm just scared that I might have forgot a value or something. Right, so just make sure there that you do that. I'll do both tables to show. Okay, so if you go on the original route that I did, I'll show you what the values will be. And if you went the other route, I'll show you what the value should be. Then you can just let me know if it was not accepted, if you got the right values. Right, so let's first focus on these lines. So if you go from that to that, remember the uncovered values are the values that you first check. Sorry, I want to highlight the uncovered values. So these values, you check the smallest value, take the smallest value. So that's 5, okay? Now from every uncovered value, you're actually going to subtract that. Okay, so we go for each of them. 41 minus 5 is 36. 32 minus 5 is 27. 5 minus 5 is 0. 9 minus 5 is 4. 25 minus 5 is 20. 11 minus 5 is 6. For the values that are covered once, even the dash stays a dash. But if they're covered once, they stay as is. Then for the values that have a cross twice, I add that small value. So plus 5 and plus 5. So these are options that should have been accepted. Well, this table too. Let me now do it just in case you had it the other way around. That one line. The one-liner. Right. So let's see. So to make another table 2. So from there you go and say, okay, what if I did it like this? Ooh, that was not a beautiful line. Like this. Let's see. So instead of that line, you would have went like that. Right, let me just delete that line for, I'll move it for now. Okay, so you would have gone like this. Okay, that's also correct. So we check what's the smallest value now. Oh, I did consider it this. Okay, smallest value is 11. All right, so 11, I take, and from everything that's uncovered, I subtract. Okay, so I'm just going to write there CA, NF, BW, H. This one is Winter Soldier, BE, Kingpin, John Doe, or Dummy. Right, Marizon, you should be able to go back to the original page and go to results somewhere. I'm sure it should be somewhere there. I did specify the option for results to show, but I'm not sure on your side what it looks like. Then going on from here, so let's see. So uncovered values, so I'm going to start with these. Uncovered values, and I subtract 11. So dash stays dash. Dash stays there. All right, 41 minus 11 is going to be 30. Let me just double check. Yeah, 32 minus 11 is going to be 21. 34 minus 11 is going to be 23. 25 minus 11 is going to be a 14. You can use Excel, but yeah, there we go. Then others would have been covered by only one line. So all of these covered by only one line, they stay as is. So we'll have a 0, a 9, and a 5, a 0, 0, 0, a 0, and a 0. Then the values that are covered twice, we would actually have to add those. So that becomes 11 plus 1, which is 12, and 0 plus 11 is 11. So those are the two options that you could have gotten. Table 2's two options. All right. I suggest you take a screenshot so that if you had the other option, you can just double check that I didn't miss maybe a value or so. Oh, it's a pleasure. Okay, so from there, you would then go and do the same process until your table is optimal. So I'm just going to show it one way because if you have the idea, you have it. And I didn't ask after that for tables, I asked for the optimal solution. So I'm going to go with the table here on the left. Okay. So from there, you would now do your next optimal check. So if I wanted more tables, I will ask again, give me the next optimal check table or conditional check table. So you draw your lines. Now, the reason why I stopped asking is because there were now multiple ways of actually drawing this least amount of lines. So you could have gone like this that we did, or you could have gone like this. Oh, why am I doing the same thing? Or you could have gone like, what would be the best there? Like this. No, you can't. I'm still at table 2. Yeah. Is this? That would give you 4, so no. What about? Oh, you had to go like this. Okay. If you went from this, of course. If you went from the other table, you would have had a different route. But I didn't want to include that and have too many options. All right, let's see what to do with this though. Smallest value is 6. Uncovered values we subtract. So dash stays dash. 36 minus 6 is 30. 27 minus 6 is 21. 34 minus 6 is 28. 20 minus 6 is 14. And 6 minus 6 is 0. For the values that are covered once, they stay the same. For the values that are covered twice, so these, you take that small value and you add. So 1 plus 6 is 7. 5 plus 6 is 11. Now, whatever method you take, I'm just going to erase so that you can let me know if you think there can be less lines, but you can then say it's optimal because you try and you go like this, and you're like, what about this and this and this? That's 4 lines. What about having it like this, oh, 4 lines. Okay, you can play around, but only 4 lines. So it is equals to the size of a matrix, so it is optimal, yes. Once it's optimal, we now get to the tricky part. All right. So we go on, we say, okay, copy our table so that we can actually check. Remember the dummy you only use if it's really a must. Right, so dummy is just if it's really a must. Right, but in the calculation, you do not include it unless if I ask you to. Now let's see what's possible, what's not possible. We can only select zeros, okay? If we look at Nick Fury, only one can assassinate Nick Fury. Who's that? Only one of them can assassinate Nick Fury. Who's that? Just want to make sure I'm not doing all of this and no one's listening because then I'll stop. Okay, you guys are typing, so I'm assuming you are listening. So you have to look at zeros, Yandere. You can only use zeros. Only use zeros. If just remember, if you went the other route, then you could have started with a different zero, but in the end it would be BE. Yes, 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 yes. Okay, so that one is done. Will I eliminate the zero for BE and Hawkeye? Will I eliminate that one? So remember, we said it can be 2. So Kenneth, do you still say yes? There we go. No, don't eliminate. Right, only if it could only be 1. Sorry. Then we've got Hawkeye here that can have 2 or even 3 if the dummy is included. We have Captain America 2. So we've got options now. We actually have some options. But which one will be eliminated by the dummy no matter what I do? Yes, Black Widow. Because there's only 1 0 and that's at the dummy. So even though we don't include the dummy in the calculation because the dummy does not exist, we actually have a solution where the dummy will be the only option or the only optimal option for Black Widow. Right, so that, no choice there, even though we don't include it in the solution, but unfortunately the dummy must be used for Black Widow. Okay, then let's see, what options do we have? So we can either go with this one and then say for Hawkeye, it could be between these two. So I'm just playing around with options. I can go with this. Then I'll be working with a 14, 25. I don't count the dummy. And then these two. Why these two? Not at the same time though, but why can I use these two? Because remember, BE can do 2. Right. So let me undo that. Which value between those two would I rather pick? Which value would I rather go with? Kingpin, yes, because we're minimizing. So we'd rather take then that one. Right, so that's where this solution comes from, where it's this one, and this one. Unfortunately, the dummy is a must. Right. I'll now go back here. Just to show you something, what if we go with, let me do this again. So what if we go with Nick Fury, because that's no choice, there's only 1 0 there to choose. The dummy, there's no choice, even though we don't include it in the calculation. But what if I go with, no, not that one. We already did that one. What if I go with this one? So if I go with that one, let's see what the values would be. So let's just do this. Did I include what the Z value would be somewhere? No, I'll write it out here. Okay, so for this one, it would have been CA and Winter Soldiers 14 from the initial table. You'll see initial table. Then Nick Fury and BE would have been at 25 there. Then you don't include the dummy. Then this one for that one would be 25. So we have a first value there. 14 plus 25 plus 25. Okay. Then what if we take a different route? So I'm now saying, what if we do something else? Let's see. Okay, so if I choose that for Kingpin, Hawkeye still needs to be assassinated. So I now have still options between these two. So again, even though it's obvious already, I'm just going to specify again. I have options between these two. Why is it not alternative? Because the one is actually smaller than the other one, and I'm minimizing. So take the smallest one. So I'm not going to go with the top, but the bottom one. Why is this possible? Because we said 2 is possible, right? It's not preferable because, I mean, I want Winter Soldier to do something, but I mean, it's something we can look into, right? So let's have a look there. So I'm just giving you some more insight there, right? So what if we went this route? What if we went with this one, the dummy, which we don't include in the calculation, and this one. So it will be then this one, dummy, but we don't include it, and that one. So even though we didn't ask, you actually had an alternative solution. So what's the differences between the two? So just look at this table, optimal. So even though we want Winter Soldier to do something, we then want this solution rather with the yellow, but we had an alternative that would give us the same result if Winter Soldier didn't do anything. So if the one solution here, you would have Winter Soldier assassinating CA, I'm just going to say in short. Then you'll have BE taking Nick Fury, and then you'll have Kingpin taking Hawkeye. Right, then for the other one, you could have had it as Kingpin taking Nick Fury instead. It's still BE and Nick Fury. King and CA, sorry. Not Nick Fury. Don't know why I said Nick Fury there. That's CA. Then you can have BE Nick Fury still, and still King taking H. So even though I didn't ask, this is alternative. You have an alternative solution. Right, same Z, different choices. Hint, hint, that might be something we ask in the future. Right, if we don't, well, then great. Okay, but you should know that's an alternative solution. Right, if the Z was bigger for this one that I tried, then it's definitely not what I would choose. Okay. Then I asked you as well, what would be the solution if I add the dummy? Well, the dummy is a value of 55, so just add it to the 64 and you'll see what that value would be. Meaning if we hire someone else, what would that value be? But just to recap, we do not add the dummy originally into the equation. Reason being, it does not exist, so we don't have an actual time there. So even though we used 55, which is the largest value, that could be maybe a value that you say, oh, it could be this value if we want to hire someone, meaning that could be the total days if we want to hire someone. But we do not actually have the dummy, so that value is technically non-existent. So adding that to our total time is not really accurate because that does not exist technically. It's just if we want to hire another John Doe, we have to consider that 55 total days could be the value that we can ask. All right? Could be. Not definite. Could be. Because a dummy does not exist. I hope this helped a little bit to recap and help you prep as well. But obviously that's just question 1. Let's see, question 2. Question 2 is pretty much one of the exercises there. So I don't want to spend much time on this. The only thing that was different that I also gave you a heads up on is the fact that you've got this table showing you who can do what. So when you can set up constraints for example, security, you can only include the members that can be security. You can't say I want this amount of security, but then I include someone who can't be security, right? So let's take, for example, let's take the team leader one. Right, So team leader, only one of the crew members must be in command. So only one. So there must be a team leader though. Number one, there must be a team leader, but only one. So hint equals, but only one. So if I go and I select team leader, I first of all have to make sure that the members can be team leader before I include them in this constraint. So who can be team leaders? Captain Kirk. I'm now stick to Captain America there. Captain Kirk, Sulu, Scotty. So if you followed our variables, that would be x1, x4, and x5. So you would have included those for your answers there. Right. You'll be able to check the answers if you want to check that. Then the average we did in class, I'm not going to go through that. You could have done the average where you divide by the size of the team, which was actually 3, and then you multiply it on the other side. Or you could have divided by variables and multiplied either side and then bring the variables to the left, which we have done in class. So I'm not going to do it again. But I'm just referring to that players team with backfield and what was it, center and stuff like that. It's the same principle. You can look at those answers to just compare this. Right. Then let's see. What else? In order to ensure scientist. Okay. Then for stealth, the average stealth. Okay, that refers to what I just said. Just one thing there. We tried to trick you a bit here with the number 3. But I mean, assessment Q gave it away, but I don't say anything. It gave away because you only have one constraint for that. So, yeah, it had to be equals. At most and at least means on the dot. I mean, at most 1, at least 1 means exactly 1 is only possible. Okay, but we gave it away for assessment Q having only one constraint to fill in. But anyway, these are your binary. So let's have a look at them. I mean, it doesn't hurt to quickly look at them, right? The objective function, they specifically ask you to pick the members with the most power. So you had to actually go and look at the power values in order to maximize the power level, right? So you had to then go and say, for my first x or x1, the power level is 10. For x2, my power level is 5. For x3, my power level is 4, 3, 2, 5, 1. Right, so that's what you would have dealt with for your objective function. And you want to, they said, get the most power of the away team, so the maximum, max 8, go to power, and then those will be your coefficients for what you want to maximize. So if that player, or in our case, member, not like the example, Captain Kirk was chosen, the value would be 1. So chosen or not, value would be 1. 1 times 10, then you'll have a power level of 10. If Spock was chosen, it would be a 1, then 5 times 1 would be a 5, etc. Right. So that's where those values would come from, the power level here. Then let's see these quickly. If Captain Kirk is in, then Chekhov cannot be. So then we check which ones are those. Let me just go there. We did specify, even though we didn't have to, but we did specify. So Captain Kirk is x1. Let's see if it will not look too small if I do this. Yeah, it's maybe not the best. You can zoom out. Yeah, that works. Okay, so we've got x1, which is Captain Kirk, and Chekhov is x6. Then they specify if Captain Kirk is there, Chekhov cannot be. So if Captain Kirk is there, That one cannot be. So this should be true. That's our definite. Then we have to play around with 0 and 1. They said nothing about if Captain Kirk was not there. So that should also be allowed. If both are 0, they said nothing about both of them must be there. So that should be allowed. However, what should not be allowed is this. They said if Captain Kirk is there, Shukov must not be, cannot be. So we need all of those conditions to be met. So we're going to say, okay, what can I do? So you could have started first with trying one of these in between, include all the trues and exclude the false. Or just check. This less than or equals to 0 is going to be false. That is not what I want. Okay, then we say no. Greater than or equals to. That would have given me a true. Greater than or equals to. That would have given me a false, which it is not supposed to be. No. Okay, so that won't work. Then we try equals. Immediately not equals, so I wanted to be true, no. So you would have tried a plus or a minus in the middle, and then some sign. So let's try plus first. We'll go plus. Okay, so plus, we go and say 1 plus 0 is 1, 0 plus 1 is 1, that's a 0, and that's a 2. I can use this. Why? Because if I make it less than or equals to 1, I'm including all the trues, and I'm excluding the false, which is perfect. So it's going to be x1 plus x6 less than or equals to 1. Okay, for the next one, both Scotty and Uhura cannot be in the white team together. Let's see. Scotty is x5. Uhura is x7. So they cannot be both. Okay. So this right here should not be possible. So I want that to be a false. Right. So that should not happen. No. I'm thinking the opposite. That should happen. Sorry. Why should it happen? They both cannot be. So I don't want them both in the team at the same time. So this must be possible. However, this must not be possible. We don't want them both. No, 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 no. Okay. Cannot be. Okay, then let's see. How about this? And how about this? Did they say anything about one or the other? Just want to make sure you guys are still with me. Did they say anything about one or the other? Any argument with regards to having these of true? You guys still there? Thank you, Danila. I see you typing. So they're saying both of them cannot be in the team. So we want them both to be 0. Both cannot be in the team. Both must be 0. So having both as ones, no, false. But when it comes to having one or the other, does it matter? You just don't want them both. No, does not matter for those. So we allow them to be true because you don't want to restrict something that's maybe possible. Okay, these are possibilities, possible. So let's see, what can we do to set this up? So less than or equals to won't work because that would be true and we need a false. No. Greater than or equals to, let's see. Yes, yes, yes. If it's only one of them, then you could go and, oh, excuse me, equals to 1 because then you only want 1. So it's like an either or. Yes, then it's going to be equals to 1. So this one's going to be greater than, we try, no, it's going to be true, so no. Equals to, true, false, no, that doesn't work. So we're forced to do that whole plus or minus in the middle. If that doesn't work, then you multiply something. Okay, so let's do plus in the middle and see how that goes. What you do for the one, you have to do for all of them. So we're going to be left with a value of 0, 2, 1, 1. Can I include all the trues and exclude the false of 2? Yes. So that would be less than or equals to 1. x5 plus x7 less than or equals to 1, because you include all the trues and exclude the false. If you want only one or the other, like the either or, yes, then you're going to say plus, but equals to 1. That's definitely true. Right. Then number 8. Let's have a look there. Number 8. So if Spock, so we're looking at x2, then Sulu x4, and McCoy x3. So if you've got this, those must also be in the waiting. I showed you a shortcut method which you could have used last week, but now we'll do it fully just to see. So if we've got Spock in the team, they, Sulu and McCoy, must also be in the team. So this I want possible. This must be possible. Okay. But what about this? True or false? Must that be possible or not possible? Perfect, false. We said they both must be, so having them not there is a problem. Then having this as a 1 and that as a 0 and this as a 0 and that is a 1, both of them also false, because we said if this x2, then both must be there, not just one or the other. So that's false, 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 false. But we never said what if Spock is not there. So whatever happens if Spock is not there, we allow it, because that is not the problem. Right, the problem is making sure that if Spock is there, then the other two must be there. But if Spock is not there, we should not limit it. Those are possibilities. All right, so let's see what we can do. Let's go directly and say, okay, let's just, you could have minus first, like you could have plus first or minus first, or plus and minus, whatever you did there. All right, so let's see. I just want to think the 1 minus 1 give us minus 1 there if we minus everything. 1 minus minus would be a 1 there. Then 1 minus 1, all of these where it's a 1 and a 1 there would be 0 and 0. Then I already see, this is not a good idea. Reason being is if I include this true, depends on maybe the other true, maybe. So 0 minus anything is going to be either 0, minus 1, or a minus 2. So that false and that false is the same as this true. So there's nothing I can do to exclude and include, because you've got the same value for a false and a true. Hint, if you've got a value that's the same for false and true, you can't do anything. So then we say, okay, but what if we plus? Would that change anything? Obviously, this is a trial and error, hey? Like I told you before, it's trial and error. You play around, you plus, but plus just has the opposite effect. But let's see. So you plus, all of them. Okay. You could have tried 1 minus 1 plus, but I mean, it says both, so it's very unlikely that that would work. Both, so they will have the same sign. We go, say, okay, if we plus that, we're going to get for this one, we're going to get 3, we're going to get a 1, we're going to get 2, a 2. Here we can either get a 0, a 1, or a 2. So if I look there, I have a false and a true, that's the same. Already I cannot do anything with that. So here with these, you have noticed choice but to multiply something in front of the value that they are dependent on, the variable, sorry. So how many are dependent on that one? 2 of them. So I usually then multiply with that amount, right? If it works, we're still going to test it. Just saying, if it works. Right, so let's see. I'm going to just use a different color. So we're going to say this becomes 2, this becomes 2, this becomes 2, 2, and anything there is 0. Anything times 0 is 0. Okay, if we use plus, 2 plus 1 is 4. 2 plus nothing is 2. 2 plus 1 is 3. 2 plus 1 is 3. 0 plus zeros is 0. 0 plus 1 is a 1. 0 plus 1 is a 1. 0 plus 2 ones is going to be a 2. So if I check there, I can see that I have a false and a true. I hate it if it doesn't want to highlight. A false and a true that's the same, so that won't work. So now I try minus. Like, okay, that didn't work. But even multiplying with something higher would not work. So I try minus. Say, okay, what if we minus? Obviously, it applies to all of them. Let's see what happens then. Okay, so you say 2 minus 1 is 0. 2 minus nothing is 2. 2 minus 1 is 1. 2 minus 1 is 1. 0 minus 0 is 0. 0 minus a 1 is minus 1, because there's 2 of them. 0 minus 1 is minus 2. So we're just doing it step by step, but all of this is for that one. Now we go and say, can I do anything now? True, true. Can I do something to include them? All. Less than or equals to 0 will include all of them. It includes the 0, it includes the minus 1, and the minus 2. Does it exclude all the ones that are false? Minus 2 is not less than or equals to 0. No. So excluded. 1 is not less than 0. No. So excluded. 1 excluded. So this works. So the constraint is then 2 times x2 minus x4 minus x3. Or you could have used that other method where I split them up and then combined them at the end. Right, but that's it for that one. You guys can see the answers, right? I see most of you already telling me what you see and whatnot. Okay, cool. Cool. Remember to email me if there's something specific that you're like, you showed this, but I don't agree. Explain, screenshot, explain. Please explain. Otherwise, I'll just sit there like, now I have to reply to you, which I could have already taken time to check instead of replying first and figuring out what. Okay, so please be specific, take screenshots if you have something. All right, then going to question 3, which was your branch and bound and cutting plane. I told you guys to please get a solution first with primal or dual before you do anything cutting plane, branch and bound related. But before you do that, when you get your primal or dual simplex, please go and actually solve a solver to make sure that you're not starting on something that's incorrect. Okay, so for this one, don't think many people struggled with the IP. It's a very basic one. I'm just making another page there. So we're saying, what are the 2 items? So we're looking at interesting human items there. It's not I can't take credit for the scenario, just the workings thing. But human heads and human limbs. Okay, so those are the things that would give you profit or revenue, right? So X1, even though we did say X1 is that, in a sense, we try to guide you. Yeah. I think it's Mr. Velgem, but you can take credit for the scenario itself. We play around with the idea and then add on and change, but yeah, the scenario itself, I think it was him. Can't remember who was the original But yeah, it's something else, hey. But give credit where credit is due. I actually enjoyed it to have something else. So let's see. X1 is gonna be then heads. Amount of heads. X2 is gonna be the amount of limbs. Right. Yes, Caitlin, good question. But anyway, so the objective function, you had to go and check what is revenue. So human heads in terms of, let's start with revenue, that would have been 27. Then revenue for limbs would have been a 40. There were also some additional costs involved, if I'm not mistaken. Were they? No. Were they literally the costs? Selling, hours. So nice. No costs. Okay. All right. Anyway, going on, what constraints do we have? So they tell us that Skynet only has 24 hours for harvesting. So we have a constraint for harvesting, only 24 hours. Then we have a constraint specifically for liquidating. It's also hours. Just writing hours, even though you don't type it, so that you make sure that everything else is also in hours. So for the X1, so X1, X2, X1, how much time does it take for harvesting? So we're looking for human heads harvesting. So you'll check there, okay, the human head requires 6 hours for harvesting. And liquidating is then 8 hours. So 6 and liquidating is 8. For X2, a limb is 3 for harvesting and 12 for liquidating. If you only have that amount available, it's less than or equals to. Okay, then you'll do that whole X1 plus blah, 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 blah. Okay. Now from there, you had only less than or equals to signs, so you would do primal simplex. Right. So from there, you would do primal simplex. Okay, so then they ask you the pivots there to do primal simplex. So just to show you here, you put it in your canonical form. Every less than gets a slack. Please do not forget to take your Z values over. Otherwise, that changes quite a lot of things. Right, so they become opposite signs. Opposite signs, okay. So do the normal, it's the max problem. So you pivot on the Z row, the largest negative, which is this one. You do your ratio test where you say right-hand side over the pivot column. Smallest one is what you choose. I'm not going to show you how to pivot again. I mean, it's been a while now. So pivot, do your pivot. Now we go on, we say in the Z row, do we still have negatives, excluding the right-hand side, obviously? Do we still have negatives? Yes. That's our pivot column. Do your ratio test, smallest positive. Right. We get an optimal table. Please go practice your dual simplex if you were not ready for dual simplex, right? Okay, going from there, we had x1 equals 2.25 and x2 equals 3.5. So we had 2 to go with. Now, just to make it clear, obviously you go choose your pivots, right? From there, let me just get to the next one. 3.3a, we asked for cutting plane algorithm first, but we specifically said take it as a mixed problem where x2 must be an integer. So you had to only cut on x2 until you get x2 to be an integer, right? But for 3.4, there we specified, even though I didn't need to, if I don't specify, I mean, you're not, okay, but if you're liquidating and stuff, you can probably say half a head. That's just weird, but yeah, half a head. So that's why I specified instead of leaving you to think about it. But But yeah, we wanted both x1 and x2 to be integers when you're working with branch bound simplex. So we are specifically, all right. Table 3.3a should be from your primal simplex optimal table. So you first need to always use your optimal table that you get, and you copy that in, and you continue from there. So you'll see there for my first one there should be that. That's why I said like whatever you filled in, I'll take. But remember, constraint 3 is the newly added one, right? So the table comes from the optimal, but then you add your new added constraint. Okay, so let's see, just a quick recap on that. So we're only focusing on x2 for cut and plain. So I don't even care about which one, what. x2, that's it. So remember, when you cut, you copy your optimal table as is, right? You go copy, and then you check, okay, if I'm going to cut on x2 where it is basic, because you can only cut on something that is basic, you go where the 1 is, and that highlight comes from that chosen one, the chosen one. Right, so that's what we choose for our cut. Then, even though I skipped the whole writing, let me do that. So you do that whole step of it's 0 x1 plus 1 x2 minus 0.16667. Don't round if you can use a fraction, right? So you could write it as a fraction if you want to, or you just try to at least make it as large as possible, not to have any rounding differences. Right, but you're more than welcome to go and say, okay, take this, go and write it as a fraction. Right, so you go to formatting here and you say fraction to not work, how can I say, with rounding and making an accuracy error somewhere. Right, but be careful. I showed you before, if you use fractions, be very careful. Go and interchange between general and fraction, because you would see if I make it, let's say minus 0.0000002, it says 0, but it's not really 0. It's just a very small, close to 0 value. So then in that case, rather than go to general, just to check, okay, is it really 0? And E, guys, E represents, it's so close that it can be seen as a 0, please. All right, E, 0, E, remember from now on, E, 0, if you didn't hear what I said. Okay, E, 0. Right, but that was that. So you can use it as is. I would actually prefer that, right? So keep a side note here is it's actually 1/6 minus 1/6. Okay, that's for S1. For S2, I'm going to check the value first. That's small enough for me to write, so I'm going to write it as is. But obviously on assessment queue, you fill in what we want, right? On the right-hand side, it is equals to the right-hand side always. So that's it there. Then you do the whole splitting. Guys, integers will disappear anyway. So if it's an integer, you can skip all of that and be like, it's an integer. There's nothing to split, and eventually it's going to disappear. So like, just get rid of it already. So I'm skipping a step. Okay, so I'm giving you some tips here. Integer, and just get rid of it. Okay, now for the fractions, you have to get a positive fraction. Remember, positive fraction. So for the negatives, you go to the next negative. So that would have been -1 is 1. So you go to the next negative. Then you add the difference. So here you would add the difference to get that value. So the difference would have been 0.83333333333333. Okay. So I would have then just gone and said, what is 1 minus 1/6? 1 minus 1/6 is the same as what? 5/6. That's for S1. Right. Sure. I'll keep it there while I explain further. So that would be 5/6 for S1. For S2, it is a positive fraction already. Well, it's a positive value from the start already. So you simply just say plus 0 S2 plus 0.125 S2. For the right-hand side, it's going to be 3 plus 0.5. Then you have to do all those steps where you say take to the left, take to the right. I'm just going to quickly click somewhere else and then I'll click again back. So you'll do that whole, okay, integers on the left and fractions on the right. When you take something over, the sign changes. At the end, you'll be left with negative. I'll write it as rather 5 over 6 is 1. And negative 0.125 is 2. Less than or equals to, first positive 0.5, less than or equals to 0. And you should not forget to take this constant to the right, so it becomes a minus 0.5. So that's where we got these values from. Okay. So if you want to see that one as well, it's purely just multiplying by minus 1 there for that one. For this one, I would have separated the integer first. All right. 0.1666 is if you did not have a positive fraction. So that is a negative 1 over 6. So you have to then go and split it into negative 1 plus the difference to get back to that. Unless if you got a positive from the beginning, but that's what I got in my optimal. But it's a negative, so you always go to the next negative and then add the difference. Does that make sense, Caitlin? Maybe something forgot. Okay. Right, so that's why I do that whole 1 plus that difference. So to get the difference, and then we multiply that. Okay, so 5 over 6. After that, you do dual simplex. So this one would be largest negative, only one, but largest negative. Inside, you have 2 negatives that you can work with. Then you do your abs, Z over constraint pivot row, and then the smallest one that you go with. Right, this one, you could have done it again. I'm not going to do it again, right? So from this one, you'll see x2, just to highlight the x2 still was not an integer. So you had to highlight that row again where the 1 is, of x2, and you had to do the whole cutting again, pivot, again, until x2 was an integer. We didn't care about x1. You'll see the x1 is 1.5, but that's not what we wanted. x2 should have become an integer. Okay, but still we practice. I mean, it's good revision to practice. And then branch and bound. Let's quickly have a look at branch and bound simplex. So there we wanted both to be integers. So here we would have gone and said we have these two, x1 and x2, that are both fractions, but we want them both to be integers. Closest one to 0.5 was x2. If they're the same difference, smaller subscript. Okay, but x2 was our choice, so we go and say the original value is 3.5, so we either go less than 3 or higher than 4. Right, we move away from that 3.5 completely. Less than or greater than. Don't now go and confuse knapsack with this, guys. Do not go and say x2 equals 3 and x2 equals 4. No, that's not how the simplex algorithm works, because you need to check everything on the other side. So if we drew it graphically, maybe it looked something like this, and you go now and say that's my decimal value. You're going to check everything, both sides. Not go and decide what solution you want to take, because that will probably skip your optimal solution or just give you infeasible stuff. Right, knapsack, you only had options between 0 and 1. So that's why we could say equals 0 equals 1, because that's the only options you have. Right, but with this, you are looking both sides, and then when you do, it checks the other variable. So when you're looking at x2 on both sides, so up or down, it checks x1's variables and give you other options for x1. Right, so please, please, please don't go and make it equals. It's less than and greater than, and you're moving away from that value. Right, then I told you copy the table for both. The less than gets a slack, the greater than gets a negative. This one is less than 3, this one's greater than 4, and it's specifically for x2. Okay, you go do that, you say, okay, top minus bottom, and the slack would have become negative, so multiply the whole row by -1. Drag it, you would have gotten this. Okay, then it becomes dual simplex, negative, only negative, pivot column. Okay, next one. You go do your top minus bottom, the E would have become positive, so no multiplying by -1. Negative, only negative, so pivot column. Okay. Now from this step, you would have seen that x1 for the 1 is actually still a fraction. So from that one, you have to go with x1. There's no choice. x1's value is 2.5, so less than 2 and greater than 3. Which table do I copy? This one. And I copy it to both. Get it ready. Okay, let me look at the other one. On this one, I got x1 as a fraction, x2 as an integer, so only x1 is a problem. x1's value is 1.5. So when I branch, it needs to be less than or equal to 1. I don't have those here. It's more down. There they are. So 2.1 and 2.2 would have been these. Okay, copy that table from problem 2. All right. Okay, going on, you would then do the same process. Add your constraints. Problem 1.1 would have given you a candidate. This one would have given you a candidate. For the others, you would have gotten an infeasible, and you would have then gotten another branch. So 2.1, x2 would have had a fraction, which you would have to continue branching. So less than 4 and greater than 5, because the value is 4.333. Okay, you would continue branching, and then you get candidates. It's a max problem, so if I ask you for the best one, you would then have to provide me with the largest one. I hope that answer was correct. Let's see. So this candidate, where is the first candidate? So we've got 187, we've got a 200 there. And going back to these, a 174 and a 161, so 200 would have been the best one there if you're maximizing. Okay. Any questions before I say that's it? Queries you can send, but guys, I'm not going to explain something again. I'll just counter argue if you give me an argument, but I'm not going to explain something again. So this is your chance to ask if there's something. But if it's specifically related to your answer and you're not, you want to tell me to look at it or something, sure. Right. Yes, of course, 2.1. 2.1, 2.1, 2.1, there we go. Just the subproblem 2.1, okay? Just let me know if I need to scroll or something. Caitlin, no posting the memo, sorry. But at least you tried. Anika, it technically fits everywhere. And that's why we don't do it as like a topic on its own. I created like a heading on its own for the ones that I thought were more difficult, but it comes in everywhere. Fixed charge, location, set covering had logical constraints, capital budgeting from week 1. Now we also had what today? Yeah, it was set covering, right? Set covering, location, fixed charge, and capital. And then on its own, it can be a topic, but I mean, it's everywhere. So sadly, it fits everywhere. Okay. Right. Go through it, do this test again. Hey, I mean, you're practicing for the next test and the next test and the next test. And I mean, having these stuff to practice again always helps. Right. Jock, yes. Combinatorial tomorrow. I think it's 11:45, so I'm sure sitting there like, please don't do it now. Please don't. So we'll do it tomorrow, and then you'll just have to then practice on your own time. Okay. But it's easy enough to practice in your own time because you'll only be left with one topic. But advice, you go practice now. Everything else, don't leave studying till tomorrow because we're doing a topic tomorrow. Right? Don't leave studying until tomorrow. Like, go do everything you need to today already to work on all the work that we've done so far, because it was difficult work. It is difficult work. The IPs are the most difficult in terms of logic. Okay, the others are just calculus related. But go through it so that tomorrow you can just focus on the new topic. And then if you're sure you're okay, you can go back to the previous stuff. Right. And do the practice test today already if you haven't already. Right? That practice question test thingy on BC Connect. Right? Please, please, please. Right. You can scroll down a little bit more, but not for every single thing though. Yeah, that's where I'm gonna stop. Otherwise it's like sharing the memo, you know. Can't do that. So just ask me specifically what you want to see. But yeah, that's it then for now. I think we're really a bit too tired to now continue. And where you missed the solution 2.1.1. So maybe just, yeah, you should be able to see everything for 2.1.1 there. Okay. Then good luck with the exercises and practicing and what. Good luck. I will then see you tomorrow.